All right, gang, today we're going to continue graphing some real-life quadratic word problems. Let's take a look at our first example. A home run is hit at a baseball game and follows the path of the equation h of x equals negative 1/200 x squared plus 2x plus 3, where x is the horizontal distance from home base and h of x is the height of the baseball above the ground when both are measured in feet. On the set of axes below, graph the function to show the distance the ball travels from start to finish. Label the axis fully. Use space appropriately. How many feet does the ball travel, and what is the highest point the ball reaches? So we saw something similar to this. And again, there was a Regents question like this once where kids had to do all of this. They had to set it up completely on their own. So it's very important that you pay attention to the values that go from start to finish. So 0 to 0 in the range over a certain domain. So let's pull up the table. We have y equals, again, negative 1/200th, which could be 1 divided by 200. Close the parentheses, x squared plus 2x plus 3. Pull up the table, and we see lots of decimal values here. So we have to really do a lot of estimating and take our time when we're graphing this. We know it starts at 3. I'm looking to see if I find a vertex. I still haven't seen it. Still increasing, still increasing, still increasing, still increasing. I see a 105, but that's still not high enough. It happens to be with a 60. See a 131 out of 80. I'm actually going to change my table setting to see if that makes it easier. I'm going to go back to 0 and go up by 20s and see if that helps. Second table. Oh, I've got some whole numbers. That makes it so much easier. So let's see here. 201, 203. Oh, there is my vertex. The 201 sandwiches the 203, making that our vertex. So we know that our height is as high as 203, but we still got to figure out our domain. Well, 400 brings us back to 3. So maybe the ball got caught at 3. We're going to make that our last point and then just draw it down to the x-axis to show that in case it wasn't caught, it would land on the ground. All right, so we have to go to 400 on our x-axis. We can do that by counting by 20s. Okay, so again, if you count by 20s carefully, it should fit to 420. So I just drew to 400, but it would go to 420. And then our height again goes to that 203. So we could probably do 20s again, every other. And that makes it as well. So again, by using the scales appropriately, they want you to spread it out. You don't want to squish your data into only a corner or a part of the graph. You want to use the space that's available. All right, so now we can start to graph those points. I'm actually going to narrow this down even more because graphing all those 20s is going to be super tedious. So I'm going to change it to 40s. So second table set, start at 0 and go up by 40. We don't have to graph every single point. Okay, that makes it a little bit nicer looking. So 0 is at 3. And again, we're going to have to do some estimating here. 40 is at 75. 80 is at 131. 120 is at 171. 160 is at 195. 200 is at 203. And then the rest is going to be symmetric with those points on the other side. So 240 is back to 195. So making sure they line up as I'm estimating. 280 is at 171. 320 is at 131. 360 is at 75. I love how it just changes my color on me as I'm working. And I did not match that up right anyway. And then 400 is back to 3. So about here. And I'm going to draw my quadratic parabola over those points, showing the curve of the baseball that was hit. All right, so how many feet does the ball travel? All right, we could say about 400 feet. Okay, and then what is the highest point the ball reaches? This is its maximum, and it's at 203 feet. So 203 feet is our answer there. All right, so that is very tedious, very time consuming. You have to take your time and be very thoughtful about how you're graphing it so it comes out perfectly like a parabola. If you get something that doesn't have that U shape, you have a conceptual error and you're not showing that you understand that all parabolas should be U shaped. All right, so you're going to try the next problem on your own. I'll be around to help you guys out.